Let us solve question number 8, guys. So what we have here, if the equilibrium constant for A giving you B plus C is K1 and that of B plus C giving you P is K2, the equilibrium constant for A to P is. It's a very simple question, guys. Let us quickly go through the options. K1 upon K2, K1 plus K2, K2 minus K1 and K1 into K2. So let us see the values of K1 and K2. So A giving you B plus C. So this is your equation 1. So what is K1? K1 over here is B into C. K1 over here B into C upon A. If you look at the second equation, B plus C giving you P, right? So this is your second equation. So K2 will be what? K2 will be P divided by B into C, right? If I add both the equations, so what do I get? Add equation 1 and 2. So as I add both the equations, what do I get? I get A giving you P. So if I'm adding both the equations and I'm getting the final equation, then what does that indicate? Then the K equilibrium final over here would be what? Would be K1 into K2, guys. Yes? So this is our answer, right? So let us match it with the options. So the answer is option 4, guys. It was an easy question, guys. Very easy question from chemical equilibrium. So let us move on to the next question. Okay. So question number 9. The reaction in which the hybridization of the underlying atom is affected. Okay. So let us check the hybridizations first of the options which are given. First one is XeF4 reacting with SbF5. So what is the hybridization of Xe over here? The hybridization of Xe over here is sp3d2. Okay. What about the reaction as it takes place? As the reaction takes place, what do we have? We have XeF3 plus and SbF6 minus. So here I can see that the hybridization of Xe is changing. That is, from sp3d2 it goes to what? It becomes sp3d, right? So I think the first option is your answer, guys, because in the first option itself the hybridization is changing. So answer is option 1. Okay. Rest all if you check. So what about sulfur over here? Sulfur will be what? Sulfur will be sp3 hybridized. Phosphorus over here will be what? Phosphorus over here will be sp3 hybridized. Ammonia over here will be sp3 hybridized, and their hybridizations will remain the same after the reaction. Again, a very simple question, guys. So let us move on to the next question. An alkaline earth metal M readily forms water soluble sulfate, okay, and water insoluble hydroxide. So let us note down a few points over here. So water soluble sulfate and water insoluble hydroxide. So if it is forming a water soluble sulfate, it has to be what? It has to be something from the top of the group, because if you are dealing with sulfates, so what happens? Sulfates of group 2, what will happen? The solubility will keep on decreasing as you go down the group. The solubility keeps on decreasing as you go down the group, right? So BeSO4 will be maximum soluble and your barium sulfate will be what? Barium sulfate will be least soluble. So what I can predict from the initial statement is the sulfate is BeSO4. Next statement, and a water insoluble hydroxide. Again, if I talk about the hydroxides, what happens with hydroxides, guys? Hydroxides, the solubility keeps on increasing as you go down the group. That is, so most soluble hydroxide is barium hydroxide. Right? Are you getting this? Okay. So solubility is increasing. So least soluble hydroxide over here is beryllium hydroxide. Yes. Are you getting this? So till the point my guess is the element is beryllium. Let us go on to the next statement. What is the next statement? Its oxide MO is very stable to heat and does not have a rock salt structure. So if I compare all the parameters which are given, so we have got it as BeSO4 and BeOH twice. If I'm talking about BeO does not have a rock salt structure. So the element over here is what? The element over here is beryllium, guys. So it was a question of S block. Okay, it was an easy question. Okay, just that we should know the solubility of sulfates and the solubility of hydroxides. Let us move on to the next question, guys.